Let's go ahead and verify this identity. Tangent squared of x plus 1 times the quantity cosine squared of x minus 1. And is that equal to negative tangent squared of x? Well, it seems that we would just multiply this binomial to that binomial. But before we do that, or before we even start the problem, we could just recognize, oh, wait a minute, this is tangent squared plus 1. Oh, little tricky. Tangent squared of x plus 1 is secant squared of x. So we're probably going to save ourselves a little bit of time by rewriting this as secant squared of x. Okay, now you could have multiplied this all through, which is probably going to be a little bit of a longer problem. And cosine squared of x minus 1, this one may not be so apparent, but this is going to be negative sine of squared of x. Let me just show you where that comes from. So we know that anytime we have a cosine squared of 1, it's going to come from this identity. So we have sine squared plus cosine squared equals 1, right? Well, let's move the cosine to the right. So we get sine squared of theta equals 1 minus cosine squared of theta. Now watch this. Change all the signs, which is basically we're just multiplying both sides by negative 1. So negative sine squared of theta equals, if I change this sign, it becomes a positive cosine. And if I change this sign, it becomes a negative. So that's why I replaced cosine squared of x minus 1, right here, cosine squared of x minus 1, with negative sine theta, negative sine theta. Okay? Now, secant squared of x is 1 over cosine squared of x times that by negative sine squared of x. And sine squared over cosine squared is negative tangent squared of x, which is what we wanted to verify.